Estimating electrical load for small additions involves several approaches. Some electricians do not always perform service calculations for minor additions. Instead, they prioritize gathering information from the homeowner. This includes inquiring about recent electrical work and the existing service amperage. Permits from previous work are valuable resources. If the addition is small, involving only lighting and receptacles, and lacks major appliances like those found in kitchens or bathrooms, a full service calculation might be skipped. The reasoning here is that the cost of a service upgrade, if needed, may not be significant compared to the overall project cost. Other electricians always conduct service calculations for every small addition. This ensures the existing electrical service can handle the increased load. Identifying potential service upgrades early prevents surprises. They also discuss future plans with the homeowner. This helps anticipate future electrical needs, such as kitchen or bathroom additions. Some electricians do not always perform a full service calculation. They instead focus on understanding the homeowner's current and future electrical needs. If the homeowner plans to install major appliances or equipment, a service calculation is performed to verify the existing service capacity. The age of the home and its existing electrical system are also considered. Older homes might have outdated systems that do not meet current electrical codes. In such cases, a service upgrade to meet modern standards may be recommended. Determining whether to perform a service calculation for a small addition depends on several factors. These include the size of the addition, its electrical load, the age of the existing electrical system, and the homeowner's future plans. Let's examine these factors in detail. The size of the addition directly impacts the potential electrical load. A small addition with only a few lights and outlets will have a minimal impact. A larger addition, or one including major appliances, will significantly increase the demand on the electrical system. Assessing the electrical load of the addition involves identifying all devices that will draw power. This includes lighting fixtures, receptacles, appliances, and any specialized equipment. Each item's power consumption, measured in watts, must be considered to determine the total load. An older home's electrical system may not be able to handle the increased load of an addition. Older wiring might have lower ampacity ratings, and the service panel may have limited capacity. A thorough inspection of the existing system is crucial to identify potential limitations. Understanding the homeowner's future plans is critical. If they intend to add more appliances or expand the addition later, the electrical service must be sized accordingly. Planning for future needs prevents the need for costly upgrades down the road. To perform a service calculation, gather the following information. Firstly, the existing service amperage. This is typically found on the main service panel. Secondly, the total square footage of the existing dwelling. Thirdly, a list of all major appliances. This includes their wattage or amperage ratings. Fourthly, the square footage of the addition. Fifthly, a list of all electrical devices in the addition along with their wattage or amperage ratings. With this information, you can perform a load calculation according to the National Electrical Code, or NEC. The NEC provides specific guidelines for calculating electrical loads for dwellings. These guidelines ensure that the electrical system is adequate and safe. The general lighting load is calculated based on the square footage of the dwelling. According to the NEC, a minimum of 3 watts per square foot is required for general lighting. This value accounts for the typical lighting needs of a residential dwelling. For example, a 1500 square foot house would require a minimum of 4500 watts for general lighting. This is calculated as 1500 square feet multiplied by 3 watts per square foot. Small appliance branch circuits are required in kitchens, dining rooms, and pantries. The NEC requires a minimum of 220 amp small appliance branch circuits for these areas. Each 20 amp circuit is calculated at 1500 volt amps. This accounts for the power demand of typical small appliances like toasters, coffee makers, and blenders. A laundry circuit is also required. The NEC requires at least one 20 amp laundry circuit. This circuit is also calculated at 1500 volt amps. This circuit is dedicated to the laundry area and is intended to handle the load of a washing machine. For fixed appliances, the nameplate rating of each appliance is used to determine its load. This includes appliances like dishwashers, water heaters, and electric ranges. The nameplate rating indicates the appliance's maximum power consumption. For electric ranges, a demand factor is allowed based on NEC Table 220.55. This table allows for a reduction in the calculated load of an electric range, as it is unlikely to operate at its maximum power continuously. Air conditioning and heating loads are calculated based on the equipment's nameplate rating. The larger of the air conditioning or heating load is included in the service calculation. This ensures that the electrical system can handle the peak demand of either the cooling or heating system. After calculating all the individual loads, a demand factor can be applied to the total load. Demand factors, as specified in the NEC, allow for a reduction in the calculated load based on the likelihood that not all loads will be operating simultaneously. This is particularly applicable to dwellings, where various appliances and lighting circuits are not constantly in use. For example, NEC Table 220.42 allows a demand factor of 100% for the first 10 kilowatts of load, plus 40% of the remaining load. This means that the first 10,000 watts of calculated load are included at their full value, while only 40% of the remaining load is considered. This demand factor recognizes that the entire electrical system is unlikely to be operating at its peak capacity at all times. After applying all applicable demand factors, the final calculated load is determined. This represents the total amount of power that the electrical service must be capable of supplying. The calculated load is compared to the existing service amperage to determine if an upgrade is necessary. If the calculated load exceeds the existing service capacity, a service upgrade is required. This ensures that the electrical system can safely and reliably handle the increased demand. For example, if the calculated load is 120 amps and the existing service is only 100 amps, a service upgrade is necessary. The upgrade would involve replacing the service panel, service entrance conductors, and possibly the meter and other related equipment. When estimating a small addition, it's important to consider the potential impact on the electrical service. While it may be tempting to skip the service calculation, especially for minor additions, it's crucial to ensure the safety and reliability of the electrical system. Gathering information from the homeowner, understanding their future plans, and performing a load calculation are all essential steps in the process. Let's consider a specific example. A homeowner is adding a 200 square foot addition to their existing 1200 square foot home. The addition will include lighting, receptacles, and a small window air conditioner. The existing service is 100 amps. Firstly, calculate the general lighting load for the existing dwelling. The existing dwelling is 1200 square feet. At 3 watts per square foot, the general lighting load is 3600 watts. Secondly, calculate the general lighting load for the addition. The addition is 200 square feet. At 3 watts per square foot, the general lighting load is 600 watts. Thirdly, account for the small appliance branch circuits. 220 amp small appliance branch circuits are required, each calculated at 1500 volt amps. The total load for the small appliance branch circuits is 3000 watts. Fourthly, account for the laundry circuit. 120 amp laundry circuit is required, calculated at 1500 volt amps. The total load for the laundry circuit is 1500 watts. Fifthly, account for the window air conditioner. The window air conditioner has a nameplate rating of 1000 watts. Sixthly, calculate the total connected load. The total connected load is the sum of all the individual loads. 3600 watts for existing lighting, plus 600 watts for the addition lighting, plus 3000 watts for the small appliance circuits, plus 1500 watts for the laundry circuit, plus 1000 watts for the air conditioner. This equals 10,700 watts. Seventhly, apply a demand factor. Apply a demand factor of 100% to the first 10 kilowatts, or 10,000 watts, and 40% to the remaining load. 10,000 watts at 100% is 10,000 watts. The remaining load is 700 watts. 700 watts at 40% is 280 watts. The total calculated load is 10,000 watts plus 280 watts, which equals 10,280 watts. Eighthly, convert watts to amps. Divide the total calculated load in watts by the voltage, typically 240 volts for a residential service. 10,280 watts divided by 240 volts equals 42.83 amps. The total calculated load is approximately 43 amps. Ninthly, compare the calculated load to the existing service amperage. The existing service is 100 amps. The calculated load is 43 amps. In this case, the existing service is adequate to handle the addition. A service upgrade is not required. However, if the homeowner were planning to add more appliances or expand the addition in the future, a larger service might be necessary. In conclusion, determining whether to run service calculations for small additions requires careful consideration of various factors. While there's no one-size-fits-all answer, a thorough assessment of the addition's electrical load, the existing system's capacity, and the homeowner's future plans will guide you in making an informed decision. By following the guidelines in the NEC and understanding the principles of load calculation, you can ensure the safety and reliability of the electrical system. Remember that local codes and regulations may vary, so always consult with your local electrical inspector to ensure compliance.